So, I'm Noah, and this is the array/area model for a division. Essentially, one of the easiest ways in order to actually show you how this strategy works is by doing it for an example problem. So, say you're making goodie bags for your birthday party. You have 585 Starbursts that you want to put into the goodie bags. You're making 7 bags for your friends, and you want to put the same amount of Starbursts in each bag. How many Starbursts can you put in each bag so they will have the same amount? Will there be some extras? So, to start this process, we essentially have your 585 that needs to be split into 7 groups. That's a pretty big number. So we're going to try to see how many we can fit into each bag before we start. So essentially, I want to put 50 Starbursts in each bag. It's a solid start, somewhere to go. Shouldn't be all too hard to work with. So we have our 50 in each bag. Our 7 goes here. And we have that 585 Starbursts. We multiply our two numbers together, 50 times 7 to get 350. Subtract the 2 and get a difference of 235. So we have our 50 in each bag, and we have 235 left. I want to try to break that down a little more, and I think I want to put 20 in each bag. So I draw another box, and I move on to the next one. So with 20 in each bag, we have our 235 that's left. 20 times 7 is 140. We subtract the 2 and get 95. Okay, so now we put 50 in the bags and we put another 20. From there, we have 95 left. I think I can put another 10 Starbursts in each bag. So I'm going to add my 10, draw another box, move my remainder, multiply my two numbers to get 70. And I have 25 Starbursts left. So from here, I can probably put 3 more in each and be safe. So my 3 goes here. 25 moves up here. And I have 21 with a final remainder of 4. Can't do anything with that 4. I want to make sure all my friends get a fair amount of candy. So from here, we add all of our base numbers together because this is how much we put into each bag. 50 plus 20 plus 10 plus 3 equals 83 with 4 left over that you can't put in the bags. And that's essentially how this model works. It's a lot of multiplication, subtraction, and then in the end, that addition that gives us that final answer of 83 Starbursts per bag. So in this model, some of the challenges that are going to arise is it definitely takes a little more time than some of the other division strategies. And because of this time take, it loses some practicality. While students can see and understand where most of the numbers are coming from, essentially where those 50, those 20, because those are self-chosen numbers, there's so much room for algebraic error, meaning errors in that subtraction, that multiplication, or that addition in the end, that there's more than likely a step that's going to cause some trouble. Another issue is the conceptual ideas of I chose that 50, I chose that 20, and those are going to be what is my answer in the end. That concept of that being my answer can get lost so easily if you lose concepts. If you lose the concept in this division rule, that it's hard in the end to find your answer. That's probably one of the reasons why, in the end, I wouldn't recommend this for an AYA math classroom. With this strategy being rather elementary in its concepts, meaning, okay, how can I break this down with these numbers? The approach for this strategy most likely will not come up in an AYA math classroom. So by that 7th grade, that first start of AYA, the concept of division being breaking down a larger number into smaller groups has been pounded into their brains in their previous math classes for years upon years. So having another division strategy to show them this same concept of division being breaking it down into simpler groups is redundant in a way, a math setting. In terms of curriculum, nothing really calls for it because it's simply just too simple.